So this is the question I'm going to ask you. How do we determine whether 0, 1 and 5 zeros and 1, which is 65, that we have recorded in the computer's memory, how do we know it is number 65 or is it ASCII-A? How do we determine that? Because whether it is binary 65 or ASCII 65, ASCII-A 65, the representation is same. This is what the memory will have. So how do we know what this is? So to understand this, let's look at some example with our own experiences. Okay, let's say there is a person who is writing somebody's age. We are going to look at 29. Okay, he is writing on a piece of paper the age 29. So he is writing 29. Okay, let's say he is written 29. Then there is another person, second person. He is going to write 29 rupees. He is taking a paper and writing 29. That he knows it's amount. Maybe the amount he has to pay somebody or give somebody or something he has to get or whatever. The amount he is writing. Okay, so he is also writing 29. Then there is a third person. He is going to write somebody's house number. Okay, I have to go there. What's his house number? Okay, 29. He is writing that. So all three people have written 29. And if you take each of the three papers and look at the paper, somebody who has not one of these three people, if they look at, they will see 29, but they don't know what exactly it means, right? So now if this person, he has written 29, now he is reading that. When he reads that, he knows it's the age, no, because he is the one who wrote it. So he wrote it as age. He didn't say age or anything anyway. He just wrote 29, but he knows he has written the age. So when he reads it, he will read it as age. Okay? Same way, this person, when he reads the 29, he will read it as, okay, 29 rupees. Because he wrote it as rupees. He wrote a amount, money. Okay? So he will read it as 29 rupees, whereas he will read it as 29 years old, this person. So he is going to read it as 29 rupees. This person who wrote 29 as a house number will read, okay, that house, okay, that is 29 number. So all three are reading 29, but he is interpreting it as age, he is interpreting as rupees, he is interpreting as house number, and that 29 could be written in various other ways, and people could interpret it in different ways, what they wrote. This is the same principle that goes into ASCII and memory, the computer memory. You have this, okay? So let's see. We'll take our old example, okay? So all three 29, all three, that is this one, and this one, all are 29. But what is 29? What exactly is this 29 is determined by the person who reads it. For him, it will be age. For him, it will be rupees. For him, it will be a house number. Okay, so let's see another example, which is the example I earlier showed you. I told you to remember this. So let's look at this number. Okay, now we have two people reading, or two readers. Okay, reader A and reader B is going to read this. Now the reader A reading and reader B reading can read it differently. For example, reader A can read this as 1, 2, 3, 4, 5, 6, 7, 8. So he wrote 1, 2, 3, 4, 5, 6, and 7, 8. Whereas this guy who's reading, he's just reading it as it is. He's saying, okay, this is 2, 4, 4, 4, 6, 6, 6, 6, 6, 8, 8, 8, 8. Whatever. He's just reading as it is. He's reading. So again, interpretation. He is interpreting it as something else. He's just saying, okay, 1, 2, 3, 4, 5, 6, 7, 8, like something like that. And his outcome is this. His outcome is this. So same number, reading differently. So what I'm trying to show you is, even in our life, we are doing that. So right, the same thing the computer is going to do. This 65, it will read it as a ASCII or as a number. It's the reading purpose, right? But what is written in here is the same thing. Okay, so let's look at the number. We want to store 209. Okay, we are going to now see how are we going to store 209 as ASCII and 219 as as binary. Okay, I don't want to talk about the extended. This will go into, if you look at the ASCII character code 209, it will be extended ASCII. That will be some character. I'm not going to talk about that for the moment. I'll show you something else. Okay, so let's look at, okay, two people are going to read this. Okay, read this 209. He reading and storing. Okay, he is going to store this number in a ASCII format. He is going to read and store this as a binary number. Okay, so let's see how those two will be writing. And he will take 2 as a digit, because it's ASCII. No, 2 we have seen already. 0 to 9 has ASCII values, right? 0, this is the ASCII value for 2. Then I'll write the ASCII value for 0 and ASCII value for 9. So this, if we interpret each of the byte as an ASCII character, you will find 2 here, which is 50. This is 50. If you take the binary value, it's 50. This 50, he will interpret it as ASCII 2, because he is taking it as ASCII. 50 is ASCII 2, and 0 is ASCII 48, and 9 is ASCII 57. So this is how he will be storing. Whereas he is trying to store it as a binary number. So he will take that and store the binary equivalent of that. You know, no? 1, 2, 4, 8, you get the weightage, and you write, okay, one of this, one of this, one of this, and you add this up, and it will, you come up to the 209. So this 209, if you store it as a ASCII characters, each digit will be separately stored. If you store it as a binary number in 1 byte, so basically, if you want to store each ASCII digit, you will actually need 3 bytes. Whereas if you want to store this as a binary number, you just need 1 byte. In 1 byte, you can put the 209. Okay, but depends on how you write. But what you have to remember is the end result, whatever you do, is all binary, ones and zeros. Okay. Right. So now let's look at another example. Okay, some more. This is again 65, which is capital A, as far as its ASCII is concerned. If it is a number, it will be 65. Okay. So again, two readers are reading this. He is going to read it as ASCII. He is going to read it as binary number. So for him, it will be an A. For him, it will be a number 65. Okay, but what is in the memory is the same thing. He is reading it as ASCII, and so he gets capital A. He is reading it as binary number, so he gets 65. Okay. So the actual meaning of data being read will vary based on the interpretation of the reader. He is reading it as ASCII, so it is A. He is reading it as binary, it's 65. What you have in the memory is the same thing. So reader X, that is this person, cannot do arithmetic. Why? Because he is read it as A. No? So he can't multiply this or add or subtract or get the average or total it up or with other ASCII values. You don't do, no. Characters you don't add up. Okay. So whereas if it is a binary number, for him it's a number, right? 65. So he can add 1 to that and make it 66, or multiply by 2 and make it 130. It's number. So numbers, you can use any arithmetic operation, no issue. So for him, arithmetic operations will be possible. For him, it will not be possible. Okay, why? Because he is interpreting it as ASCII. He is interpreting it as a number. So for number, arithmetic is fine. For characters, arithmetic is not fine. Okay, remember that. So depending on how you are going to deal with it, but in the memory, it is the same thing. But he has read it as a character. So he can't go and divide this by 2 or multiply it by 100 or do any calculations with that. Okay, just remember, he can, because he is read it as a number. No issue. That's what I am trying to show here. Okay, so the writer who stored 65 in memory as 65 will read it as a number. Number 60. If you are writing binary 65 and you meant to have it as a number, you will read it back as number. Whereas the writer who wrote 65 thinking it's ASCII, he has to read it as ASCII, because for him, what he wrote is ASCII. And since the memory doesn't allow anything else to be written, it's in binary. Okay, both are writing 65. If you look at the memory, both of them will have the same memory, 0 and 1, and whatever the zeros and 1, which is the 65 or binary. But for the first person, he wrote it as number, so he will read it as number. Second person wrote it as ASCII, so he will read it as ASCII. Okay, so but the memory will not have any idea of what is stored. As far as the memory is concerned, it is a series of zeros and ones. So you can't go and ask memory, this, what do you have here, or what do you have here? Everything is zeros and ones. Memory won't know whether it is, the reader is only going to interpret it and read it in accordingly. Okay, so memory is like that, all zeros and ones. So is this ASCII? Is this number? Who knows? Person who wrote will know, okay, this is ASCII. I'm going to read this as ASCII and I'm going to read this as number. But, so it depends on that. But the end result in the memory is the same. Remember that. Okay, right. So that brings us to the end of this, to give you an idea of ASCII and how these representations are done and how all the other characters in the computer keyboard are handled. This lesson will help you, I hope. So thank you very much. We'll see you in the next lesson.